So let's continue with a very, very brief history of the internet. So sure, you can look up the history on many, many pages with a lot of explanations, but some of the basic ideas, they started back in 1969 with this very, very simple drawing connecting four computers and saying, okay, that's basically the starting point, the initial seed of the internet, the ARPA network, four nodes connected, exchanging some data. It developed pretty much, you will agree, and today, well, we don't know exactly how the internet looks like. This is a mesh network somehow with some structure. We'll discuss this. But today, one of the big challenges is, can we manage the complexity? Can we handle the complexity? What does it mean if we introduce a new service? This service relies on another service, relying on maybe many other services, which then again rely on whatever service relying on, we don't know, and finally on some networks. And this complexity, we don't know exactly what it is, but it's a function of the number of nodes. And you just learned that with the Internet of Things, we have billions of nodes. So, yeah, number of nodes. But it's also a question of the topology. So is it a very simple hierarchical structured topology, or is this a kind of a, we don't know, more anarchic topology? Is it static? Is it more dynamic, the topology? Who is controlling the topology? But also traffic patterns. Is it simple email? Is it voice, mixed video, plus file download? Is it very bursty traffic? We'll discuss what bursty means. Or is it more this kind of very smooth, constant bitrate traffic? But maybe constant bitrate that is very delay sensitive, so we have to have a very low jitter. So we don't know, is it kind of a very stable application? So it's a kind of a compute center, big machines in big buildings, etc. Or is it more this kind of mobile usage, everyone running around? Is it more ad hoc setting? So how much legacy do we have in the network? We'll learn that we have a lot of legacy in the network, and we cannot just come up with a brilliant new idea and ignore all the legacy. No, we have millions of installed networks. And are there some more parameters? We don't know. So just to give you an example about complexity, just have a look at the information flow between banks on the left side of this figure and industry on the right-hand side, just by looking at the autonomous systems. We will recap all the ideas of autonomous systems, but this is something you should basically know from the basic networking course. So if we look how the information knows, we do not always know where the traffic flows. We try to control this somehow using protocols like BGP, routing, etc., but we do not always know it. So this is pretty complex, and if I say, okay, there's one system connected to another one, the information flows somehow, which is good, so it works and I don't have to care. But on the other hand, maybe sometimes it's a problem, because what happens if then suddenly one of the machine here in the middle breaks down? Do we automatically reroute across another autonomous system? That's the hope. But what does it mean, for example, for delays and jitter and maybe also security? So we don't know. And if something happens, so for example, if this autonomous system breaks down for whatever reason, we may run into problems, or we have a huge overload in one of the other systems. So we'll discuss these issues. We'll also discuss how we can secure certain routes, that we know where the traffic is going, etc. And please be sure, many things happen in the network. There are many, many, many incidents like the Baofeng attack, and where you have a certain amplifications of attacks. So someone wants to attack someone else, and suddenly you have a certain amplification in that, and the whole network is down. Or a certain country reroutes traffic, as it happens with Pakistan rerouting traffic for YouTube, trying to block certain traffic, by this way rerouting it, or that the US is blaming China for, capturing certain traffic, rerouting this traffic for whatever reason. So there are many, many, many reasons why on purpose or by accident traffic can be rerouted, and that's one of the big problems in the internet. You can do this on purpose. Then we are in the field of cyber attacks. So this course is not mainly focusing on security issues, but we will touch it from time to time, because you cannot discuss networking without discussing security of the network. And just one example, April 2022, there were certain incidents done by the Conti Group. And the result was that on May the 8th, 2022, the president of Costa Rica declared a state of emergency as a result. So basically, many state institutions could not work anymore. And this was one of the first times really an entire state was, severely affected by cyber attacks. And we have these command and control centers with the situation maps showing who's attacking whom, etc. We do not always know, was this really an attack on purpose against, in this case, Costa Rica, or we read some declarations afterwards, after this attack, that this was a performance demonstration by the attackers. Was it politically motivated, or was it, simply organized crime? We see many attacks caused by organized crime. That's just another means of getting money, like ransomware, etc. Or are there even governments in the background? Or sometimes, where's the difference between certain governments and organized crime and political motivation? Where no certain nations, they do this on purpose. Well, mainly to make money. If you think of these things, okay, it's a problem if governmental institutions are down, then maybe you cannot send in your tax declaration. Okay, maybe some people are happy about this, but this is not really a funny thing. Just think of industrial control systems. Industrial control systems are still vulnerable to many, many malicious cyber attacks. Think of control systems you will not update every other week, like you do, for example, with a mobile phone or your desktop system, but control systems similar to healthcare systems, you install them, and then typically you don't touch them. From time to time, there may be an attack, but as has been shown, the control software is not always up to date, and quite often it's even unprotected. So quite often it's the normal technology. And the vast majority of all computers on this planet are embedded control systems. Well, maybe you have a mobile phone, a desktop computer, a tablet, maybe a smartwatch. Okay, 4 computers, maybe a 5th one. But then think of cars with 60 little embedded computers, or an airplane with 6,000 embedded computers, so many, many, many more, or the dishwasher and the washing machine and whatever, even light bulbs. Lighting systems come with integrated computers, because then you can control them, change the color, etc. So there are many, many vulnerabilities. Your smart meter at home, SCADA systems in power plants, and many of those systems are open. Why? Because originally they've never been designed for internet connectivity. And then suddenly someone comes and says, oh, isn't it a good idea to connect those systems to the internet? Because then I can access them with a very nice app using my smartphone. Okay, then smartphone, using internet technology, and then we write a kind of a wrapper and blah, blah, blah. And then we connect our SCADA control system to the internet. Great, and now I can see what's going on at home. But the system itself was never designed from the very beginning with this in mind, with this internet connectivity. So there are certain search engines you can use to access these systems. So main problem is if these control systems control, for example, the power grid. Well, we all know no communication without power, but also no modern power grid without communication. So that is one of the big problems. Now we all think that, okay. Well, if we talk about power grids and critical infrastructures, yes, these are all the experts and the professionals. And yes, there are very many experts in their domain. But think of the problem. We now connect a new technology. Well, yeah, 1969, but still it's new in some areas. We connect them to another system, never designed for this type of connectivity. And then we have the problem that in the end, only very few know the ropes in case of emergency. And talking to some of the insiders, they tell us, okay, don't think of the internet as being the Enterprise in Star Trek, well, hyper modern, whatever. And well, look at this figure. It's more this sailing ship with a small crew pulling the ropes. So there are maybe some 1,000, 2,000 people worldwide that can really bootstrap the internet in case of a serious situation. So breakdown of domain name system, BGP under attack, etc. The problem is many cause malfunctions. So this is why someone drew this picture of, well, this is this old ship where we have our well-known layers, physical layer, data link layer, network layer, and then many are shaking up there. There's the wind coming and shaking this ship, and we hope that these lower layers are very robust. So we hope that this ship will not sink, no matter how strong the wind is, and the political layer, whatever, all the applications. And so we hope that this works. But the more you put on top of this shit, the more doubts we have that this ship is stable. So, and the problem is, we have so many applications and too many people talking about this and giving us good advice without knowing anything. I see pictures like this that, okay, this is Facebook, and this is somehow the internet, and the core of this is WhatsApp and Facebook and Instagram. Then as an engineer, I think, oh my God. Okay, too many people talk about this and they don't know what they're talking about. Okay, the core of the internet is not Instagram, Facebook, or whatever WhatsApp is. So we will talk about the advanced topics of the core of the internet. Okay, so we have certain technical issues in the internet, but we have also many political issues. Think back of the Arab Spring, we had a sudden shutdown of the internet. So there are also political issues when it comes to internet connectivity. 2022, you also saw many restrictions in the internet. Here you see in different countries cutting internet connectivity, Russia, Azerbaijan, Iran, etc. So these are the top 10 in 2022. So many political reasons and all these technical things. So maybe a software bug, but also political issues, but also strange applications, cyber attacks. They all come together and they all shake this ship, internet. So we all want to make communication robust. And this requires way more than just walking on this very thin ice. So we're talking AI and cloud and cool 5G, 6G communication, fog computing, machine-to-machine, edge computing, voice over IP, voice over LTE over IP, etc. So nice, we all like this, but you should learn what's underneath this thin layer. There we still have a lot of legacy systems, complex systems. Well, we also have people attacking the systems, cyber war going on, organized crime, malware, monocultures. You saw that, we all rely on this nice Amazon Web Service. Is this a good idea? We still have many legacy systems. Well, you will learn that, okay, TCP/IP is running the internet, but we all know these are protocols from the 80s, not really designed for today's challenges. But it's so convenient to use a certain service. So is this a good idea, or shouldn't we think way more about networked security, security from the very beginning, how to create a very robust communication core, no matter what shakes up there, this ship, so the winds of new application services. Maybe we should also have more robust ad hoc structures that help each other out in case of emergency. Maybe you should think of more decentralization, not relying on single service, but on multiple services, secure software, hardware, redundancy, etc., resilient systems. Yeah, we have to do a lot more also when it comes to education legislation. So there are things like the Cyber Resilience Act in the European Union, where we really try to support more resilient, more robust systems also from the legal side. And we have to think of business models that support more robust systems, and that business model that do not only support time to market, cost pressure, and build those shitty systems and bring them to market. This is not the way to go. Okay, I was briefly talking about the history. So what is the future of the internet? Okay, I don't know the future, so let's ask an AI. AI knows the future. So, it's definitely a more and more virtual world. So we see more of this mixture of virtual, augmented reality systems. We have this more immersive experience, more interactive. So, we open up new ways of communication, definitely. So we saw in the very early days of the internet, keyboards. Now today, I use voice with my smartwatch to type, to speak an SMS or a message. So we'll see holograms, brain-computer interface, etc. Definitely. And of privacy, that's an important issue. Well, already I think 15 years ago, so someone wrote, the end of the privacy is there because we collect so much data. And we know basically everything about everybody. And you do not even need an account at one of these big companies. The companies know basically everything about you, if you like it or not. We see a transformation of all the public and private structures, not only the markets, but also education. You see it on your own. I mean, how do you learn today? It is still the classical book. Yeah, great, if you like it. But maybe you like more watching videos or going to a lecture or a mixture of this. We see change in politics. You cannot really isolate your people in a country from the others. Yes, some countries still try to do it, but this will fail sooner or later. Also, transformation, healthcare, health consultation of doctors, etc., social interaction. Then we will see more and more fusing of artificial intelligence and IoT, the Internet of Things, so smart devices, sensors, generating massive amounts of data. And together with data science, we'll get new insights. What's happening in healthcare, in social structures, to society, etc. For good or bad, we'll discuss this also during this lecture. And then the AI of Bing also told me, okay, the Internet of the future will respect human rights, diversity, democracy. I have my serious doubts about this. We can discuss this also during the course. Again, some questions and some tasks. So please go ahead and check the history of the Internet on your own to get a better understanding of the developments. The Internet definitely did not start with the World Wide Web or social media. It's not WhatsApp or Snapchat or TikTok. Then have a look at the Internet. What is the Internet? How does it look today? Do we know it? How much do you see from the Internet, whatever it means? Then think of vulnerabilities of the Internet, vulnerabilities of the services of the Internet. We'll discuss this. What are causes for vulnerabilities? And then if we think of vulnerabilities, it's also about people. So why is technology not everything? What else is needed when it comes to services, to vulnerabilities, to all these different aspects?